Welcome to my channel once again. This is Teacher Atari. In our today's topic, we'll be talking about electrolysis of copper sulphate. Electrolysis of copper sulphate. Copper 2 sulphate. So in this, we said copper sulphate will undergo dissociation reaction. We said copper 2 will decompose to give C2 plus SO4 minus. So when it is dissolved in water, water will dissociate as well to give hydrogen ion plus OH negative. So by so doing, we said this positive side before now is cation. So this negative part of it is what? Is the anion. So in our previous lesson, we said the positive ions will migrate to a negative pole, which is the cathode, while the negative ions will migrate to the anode, which is the positive pole. So what happened at the cathode? At the cathode, we said at the cathode, oxidation reaction, reduction reaction occurs. We said C2, Cu2 plus, and hydrogen gas, hydrogen ion will migrate to the cathode. So by so doing, one of them will be preferentially discharged. Since hydrogen is higher than Cu plus copper ions, we said copper ion will be preferentially discharged. We said C2 plus, we acquire an electron. We acquire 2 electrons. This makes this the cathode to be thicker. We're going to have copper to give a metallic copper. Since 2 electron is given out. So at the anode, we said SO4 2 minus and OH negative will migrate. Since OH is lower in the electrochemical series, we said OH will be preferentially discharged. So OH, when it's preferentially discharged, it loses an electron to give hydroxyl group plus an electron. So OH is not stable. OH plus OH will give us water plus oxygen. Oxygen is not stable. Oxygen atom is not stable. Oxygen atom will react with oxygen atom to give oxygen gas. As I've said before now, whatever that happened at the cathode is known as cathodic half reaction. The reaction that occurred at the cathode is known as cathodic half reaction. We said whatever that happened at the anode, the reaction that occurred at the anode is known as anodic half reaction. So this reaction, if we should check this way, as we have balanced this equation before now, we say whatever that is stable is being added to this equation. Equation started with hydrogen ion and it moves down to water. Water is stable. I'm not including this OH because it's not stable, and I'm not including this oxygen atom because it's not stable. We are adding this to be our final product. So a reaction started with OH negative to give water plus oxygen gas. So now we have 2 equations. We will have one at the cathode, which is the cathodic. This is the cathodic, and this is what is the anodic. So by so doing, you are going to balance these 2 equations. In our previous lesson, we are able to balance this equation, with an electron. Here, we say we have 2 hydrogen here, we have 1 hydrogen here, we have 1 oxygen here, 2 oxygen, that is steric. So by so doing, let's add 4 here. 4 times 1 here is 4 hydrogen. We balance the atom and the ion. Here, to balance this atom, we're going to have 2 here. We have 2 oxygen plus 2 is 4. That is balanced. Here is 4 electron. We're going to have 4 electron. Yeah, let's take this 4 down to this point. If we should have here, since there is 4 electron here, let's balance these ions first. we should balance the ion, 2 times 4 is going to give us 4 ion. So the atom, let's balance the atom. We have 2 copper here. We are going to have 2 copper here. So we said the algebraic addition of this cathodic half reaction and the anodic half reaction will give us the overall reaction of this electrolysis. We said overall reaction, we said all the reactants should be at the left hand side, while the product at the right hand side. This is the reactant at the cathode. This is the reactant at the anode. We're going to have 2 copper 2 plus 4 OH negative to give plus 4 electron to give the product here is 2 copper solid plus 2 mole of water plus 2 oxygen plus 4 electron. As I've said before now in our previous lesson, this electron will can't go without this electron. So the overall reaction here, the overall reaction in the electrolysis of copper sulfate is 2 copper 2 plus 4 OH negative to give 2 copper solid plus 2 mole of water plus oxygen gas. So at the end of this electrolysis, we said at the cathode, a metallic copper is liberated. So at the anode, an oxygen gas is liberated as well. So this there's a question that comes within this topic. So for us to know the state of the solution when this copper and this OH is discharged. When this copper 2 plus here is discharged with this ions here during the electrolysis, the solution is now left with hydrogen ion and SO4 2 minus. So by so doing, these 2 ions makes the solution to be acidic. Students should be very careful. Should be aware of this question, that when copper 2 plus and OH is being discharged during electrolysis of copper sulfate, what is the nature, how is the nature of the solution left? The nature of the solution becomes what? Is acidic. It's acidic. This is JAMB question, WAEC question, and NECO questions that comes around from this topic. So by so doing, we now move down to the next topic known as electrolysis of brine. Electrolysis of brine. Electrolysis of brine. Electrolysis of brine. Brine. A brine is sodium chloride. Sodium chloride is a very important method of obtaining chlorine gas. You know, the chlorine gas is a very important gas and is very poisonous as well. It is used to kill germs and other useful things in the industry. So this is a very commercial method of obtaining chlorine gas. So when sodium chloride dissociates, it's going to give us sodium plus Cl minus. So it dissolves in water as well. It's going to give us hydrogen ion plus OH negative. We said this will move to the cathode, this will move to the anode. So at the what? At the cathode, reduction reaction occurred. Since sodium is higher in the series, we said hydrogen ion is preferentially discharged. When it is preferentially discharged, it acquires an electron to give hydrogen. Hydrogen atom is not stable. Hydrogen atom will react with hydrogen atom to give hydrogen gas. So this is what happened at the cathode. This any any electrolytic reaction that occurred at the cathode, we said is known as cathodic half reaction. So let's at the anode, the negative ions will move to the positive pole, which is the anode. At the anode, this is at the cathode. At the anode. So we said chlorine ion and OH ion will migrate. So by so doing, we use the effect of concentration will play a very good role here because they are very close. We said concentration promote the discharge of an ions. So because of the affinity of chlorine as well, chlorine is preferentially discharged. So when we said at the anode, oxidation reaction takes place. So what happened? It's going to lose an electron plus what? To lose an electron. So what happened here? Chlorine is not stable. Chlorine plus chlorine to give chlorine gas. So before we balance this equation, we said during the electrolysis of brine, at the cathode, hydrogen gas is produced. At the anode, chlorine gas is produced. The anode is prepared in such a way that will enable these substances to be liberated easily. So as so doing, whatever reaction that occurred at the anode is known as anodic half reaction. All right, so the next step is for us to balance this equation. All right, we said let's bring out what happened at the anode. Let's bring out what happened at the anode. At the anode, we said the reaction started from here and it ends here because it's the most stable one. We say hydrogen plus A minus to give hydrogen gas. So at the cathode, what happened at the cathode? This is at the cathode, we say cathode, which is known as cathodic half reaction. At the anode, we said chlorine started from here. Chlorine to give, yeah, this one is stable. We said chlorine gas plus electron. In this now, we must balance this reaction because before we can add these two reactions to form the overall reaction. We said, yeah, we must balance the atom first. We have two chlorine here. Let's have two chlorine here. Let's have two chlorine here. Since we have two chlorine, so that is going to give us two electron. Yeah, we have hydrogen gas. So let's balance the atom. Two hydrogen gas, 2 times 2 is going to give us 2 electron as well. For us, if we should add this equation, will give us the overall reaction. So overall reaction, we give all the reactant will be at the left hand side, while the product will be at the right hand side. So the reaction started with 2 hydrogen ion plus 2 chloride ion plus 2 electron to give hydrogen gas plus chlorine gas plus 2 electron. 2 electron cancel 2 electron. 2 electron cancel 2 electrons. So the overall reaction now become 2 hydrogen plus 2 chlorine negative to give hydrogen ion gas plus chlorine gas. So by so doing, we said at the cathode, what is produced is hydrogen gas. At the anode, chlorine gas is produced. This brings us to the end of this lesson. Please do well to subscribe to these channels and turn on your notification bar for new video. Thank you.